All right, starting where we left off, although I've kind of a little bit of a head start because I didn't realize I wasn't recording. Here's what we got. So we're doing 6x times 3x minus 4. 6x times 3x is 18x squared. 6x times negative 4, 6, 12, 18, 24. So minus 24. For this one, doesn't matter where you start. I guess I'll go ahead and start with these two guys here. We'll box them. We got x minus 1 and x plus 9. X times x is x squared. X times negative 1 is negative x. Oops. X times 9 is 9x. 9 times negative 1 is negative 9. We combine our x's. We are left with x squared times, is x squared right? Yeah, x squared plus 8x minus 9. All right, now we're going to distribute again. X squared times x squared is x to the 4th. X squared times 8x is going to be plus 8x to the 3rd. X squared times negative 9 is minus 9x squared. All right, last one. Distribute. 3 times 12 is negative 36. X squared. 3x times positive 1 is plus 3x. This one says, set up the quadratic formula to solve the equation. Your quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, in your quadratic equation, if it's in standard form, your a is in front of your x squared, your b is in front of your x, your c is your constant. So our a in this case is going to be 5. Our b is going to equal negative 2. My c is going to equal 9. So if I go to plug this in my formula, we have negative. Our b is negative 2 plus or minus the square root. B squared is negative 2 squared minus 4 times my a is 5. My c is 9 all over 2 times 5. They're usually not going to leave it like this. They're usually going to simplify this. Negative and a negative, since it's positive 2, plus or minus the square root of negative 2 squared minus 4, whoops, times 5 times 9, all over 2 times 5. And the question on your test is just going to want something like this, where it is set up. They're not going to ask you to actually solve it all the way. Listen. All right, for question number 36, this area and perimeter. It says that the formula for your area of a triangle is 1/2 base times height. So 1/2, our base is 4x plus 10. Our height is 2x. I'm going to go ahead and deal with these first. 4x times 2x is 8x squared. 10 times 2x is plus 20x. We still haven't dealt with the 1/2, so we would multiply everything inside our parentheses by 1/2. So it would be 4x squared plus 10x. For perimeter means add all your sides. If I'm looking here, we're going to combine our x's. Remember, we're not adding the inside. Perimeter is just the outside. So 3x plus 4x plus 4x, well, that's 4, 8, 9, 10, 11. X, add just our numbers now. We got 10 plus 5 is 15, plus 8 is 23. Unless my math is wrong, let me know. This one says, which of the following is not a perfect square trinomial? As a reminder, PST has to be 3 parts. The first and last part have to be perfect squares. And to check your middle term, it's 2 times A times B. So for example, if I'm looking at this one, x squared is a perfect square, x times x. If there's no number in front, it's 1. 25 is a perfect square, it's 5 times 5. So to check the middle term, we would do 2 times 1 times 5. 2 times 1 is 2, 2 times 5 is 10. Is that the number in the middle? Yes. This one is a PST. Checking our next one. X squared is a perfect square. 4 is a perfect square. If there's no number in front of x squared, it's a 1. Checking our middle term. 2 times the square root of 1 is 1. The square root of 4 is 2. 2 times 1 is 2. 2 times 2 is 4. Our middle term works. That's a PST. On this one, x squared is a perfect square. 12 is not a perfect square. Here is our culprit. If I wanted to check the last one, x squared is x times x. 36 is 6 times 6. If there's no number in front of x squared, it's a 1. Square root of 2 times the square root of 1 is 1. Times the square root of 36 is 6. 2 times 1 is 2. 2 times 6 is 12. We are good. Which of the following will result in a perfect square trinomial? If you have a PST or you are trying to complete the square, PST, or if you're trying to complete the square, you have to do your b divided by 2 squared. So in this case, our b is negative 16. So negative 16 divided by 2 squared. Negative 16 divided by 2 is 8. Negative 8. Negative 8 squared is positive 64. Marcus is a diver. One of his dives can be modeled by the equation y equals, I think that's negative 4.9 t squared plus 8t plus, is that 10? You'll have to excuse how mine looks just a little rough. I'm going to go plug that in here. Y equals negative 4.9. I'm going to do x squared instead. Oh, no, I'm not. Apparently, y equals negative 4.9 x squared plus 8x plus 10. We're looking for about how long did it take him to complete his dive. Well, we're not going to have a negative amount of time. So I'm going to look here. I got 2.462. I'm just going to go ahead and round it up to a nicer number. I'm going to leave it as 2.5. Okay. Which of the following quadratic functions has zeros, which remember, once again, are your x-intercepts, at 6 and negative 8/5? Once again, this is another calculator question. You're just plugging it in. You're looking at your x-intercepts. I'm not going to spend time plugging it in. Our answer is D. All right. Which of the following functions has x equals 0 as a 0? Once again, this is another plug-in question. It's another plug-in question. I've been skipping some of the plug-in questions, so I'll go ahead and plug in these two. So for the first answer choice, they gave us f of x equals 15 x parentheses x minus 4. Bam, we're already done. This one has a 0 at 0, 0. Done. Our answer is A. For 42, here's our equation. F of x equals negative parentheses x plus 1 x minus 8. Here's my graph. I'm looking at my zeros. I got one here at negative 1. I got one here at, oh my gosh, positive 8. Oh, no, da, 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 da. Please switch. Please just switch back. Don't have to start over. Okay, so negative 1, positive 8. Our answer is C. Once again, PSTs we kind of talked about on the other page. So, x squared is a perfect square. 25 is a perfect square. If there's no number in front of x squared, it's 1. To check the middle term, we do 2 times the square roots. The square root of 1 is 1 times 25. The square root of 25 is 5. 2 times 1 is 2. 2 times 5 is 10. Our term in the middle is good. This is a PST. 4x squared is a perfect square. 9 is a perfect square. To check our middle term, we do 2 times the square roots. The square root of 4 is 2. X squared is x. We're not going to write that down. The square root of 9 is 3. 2 times 2 is 4. 4 times 3 is 12. This is a PST. This we already know is not a PST. It only has 2 parts. This is actually a dots. Here's how I know it's dots. It's 2 parts. It's subtracting. There's no just regular x term. And these are both perfect squares. 3x and 4. Checking this one. X squared is a perfect square. 4 is a perfect square. To check the one in the middle, we do 2 times the square roots. The square root of 1 is 1. The square root of 4 is 2. 2 times 1 is 2. 2 times 2 is 4. Got it. Double check this last one here. See if it's a perfect square or not. 64 is 8 times 8. X squared is x times x. 1 is 1 times 1. Check our middle term. 2 times the square root of 64 is 8. Times the square root of 1 is 1. 2 times 8 is 16. 16 times 1 is 16. We are good. (44) says factor completely. First thing you should always do is check for a GCF. We do have a GCF on number 44. It is 9. Not 9, it's 5. Oh my gosh, so we're going to divide everything by 5, because that's what our GCF is. So it's going to be 5 parentheses, 9g, now you know why I was thinking 9, squared, plus 4. So, or is that plus or minus? Nope, that's a minus. Whoops, minus 4. Okay, well, it's not factored completely. All I did was took out my GCF. This is a dots. 2 parts, subtracting, perfect square, no just G term here. So I can go ahead and set up my parentheses. 5 parentheses, it's going to be 3G and 3G because of our 9. 4 is 2 and 2. If it's a difference of 2 squares, they're going to have different symbols in the middle. Alright, this one is not PST, it's not dots. I'm going to have to try and box this one. We got 5p squared. We got a plus 3. So we need things that multiply together to get 5p. Well, that's just 5p and 1p. Okay, well now we need things that multiply to get 3. We got 3 and 1, and that's it. Well, if I put my 3 here and my 1 here, that would get me 3p and 5p. And there's no way 3p and 5p can get me 2p. Well, let's say I switched it. If I put my 3p here, my 3p, my 3 here, oh my gosh, my 1 here, that's going to give me 1p. That's going to give me 15p. There is no combination of where I could put these numbers to get my middle term. If that's the case, we call that prime. It means it cannot be factored. It's already as simple as possible. All right, on this one, we do have a GCF. They all have, in case you want to see it visually, we have 2m to the third plus 5m squared minus 3m. So even though they don't have a number in common, they all do have an m in common. That's the GCF. So I'm going to divide everything by m. So we got m on the outside. We have 2m squared plus 5m minus 3. Now that I've done that, I can check for dots or PST, which is neither. And then I am going to plug into my box. Got 2m squared. I got negative 3. We already know we need 2m and m. So things that get me negative 3 are going to be 3 and 1. We just need to figure out which one's going to be positive, which one's going to be negative. Where do I put it? Or if you wanted to, you could do your big Texas. Remember, this is your A times C. This is your B. 2 times negative 3 is negative 6. My B is 5. We need things that multiply to negative 6 that add up to 5. Well, things that multiply to negative 6 are like negative 2 and 3, 2 and negative 3, negative 6 and 1, 1 and negative 6. Which one of those is going to get us a positive 5? This one, so that's what goes in our box. Negative 6m, and we have a 1m. I put them in the wrong spot. Do you know why? 2 times nothing is going to get me that 1m. So I'm going to put my negative 6 here. I'll put my positive 1 here. Let me fix that. M times positive 1 gets me a positive 1m. 2 times negative 3 gets me a negative 6m. Negative 3 times positive 1 gets me negative 3. So my final answer, I'm going to write it above, would be m, parentheses, 2m plus 1, m minus 3. So it says circle all equations that represent the function. Okay, so here's our graph. What I would do, personally, is I don't have to solve all of these. So I'm going to pull some points from this graph. So for example, we have an x-intercept here at negative 3, 0. We have a point here at negative 2, negative 1. Got a point here at negative 1, 0. And then we technically only really need those, but if I wanted another one, we have one at 0, 3. I'm going to go put those points in my calculator, plug in the multiple choice, see which ones go through all those points. So plus sign, table. We got negative 3, 0, negative 2, negative 1, negative 1, 0, and 0, 3. Okay, so if I plug in A, it says y equals x squared minus 4x plus 3. Does that go through our points? No. So then I'll check B. B, we have x plus 2 squared minus 1. Oh, y'all didn't even tell me. There we go. Look, that's going through all of my points on my graph. So B is good. All right, now I'm going to check C. So for C, we got x plus 3, parentheses, x plus 1. Oh. So what happens when I look away and then look up to see what is actually in my graph? There we go. That goes through all of our points. C is also a good one. All right, now I'm going to check D. Make sure it's properly erased. You got x minus 3 and x minus 1. Absolutely not. Check E. X squared plus 4x plus 3. There we go. That one goes through all of our points. And check my last one. X minus 2 squared minus 1. No. So our answers would be B, C, and E. So it's just a matter of pulling some points from the graph and then plug in your answer choices, see which ones actually go through those points. All right, y'all. We're on the finish line. 4 more to go. Okay. So the sequence can be generated by using, and you can't really read it, I'm not gonna lie. I think it's supposed to be a to the n minus 1, I think. And a sub 1 equals 3. So they're saying, hey, the first number is 3. Well, what are they telling us here? Are we adding 2? Are we multiplying by 2? Because when we're talking about sequences, it has to be one or the other. Arithmetic adds the same number every single, or subtracts the same number every time. Geometric multiplies by the same number every time. Well, it says A, it says 2a sub n minus 1, so we're multiplying by 2. So if I follow that pattern, 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. For number 47, they said f of x equals x squared. Well, I'm going to go plug these other ones, all of these technically, in my calculator so I can get a rough sketch of my picture here. So we got f of x equals x squared. And then for answer choice A, they gave us, or question A, they said g of x equals x plus 2 squared. Here is my new graph. So we have a new point at -2, 0. And I see we also have a point at 0, 4. And I'm just going to make a rough sketch. It doesn't have to be perfect. I do want to point out that hopefully we noticed that this moved towards, this was the original one. Here's the new one. It moved to left 2. All right, now I'm going to plug in B. So it says x squared minus 2. Okay, so now we have a point over here at 2, 0. We got a y-intercept at 4, 0, 4. This time we move towards the right 2. So here's kind of what mine looks like right now. It's not perfect, it's not completely accurate, it's just a rough sketch of what it looks like. All right, so for G says x squared minus 2. So let me go get that in there. X squared minus 2. Okay, looks like this one moved down 2. We have a point at 0, -2. We have a point at, is this a nice point? I'll try to get around 1.5-ish. It's not going to be perfect. It'll be okay. So it went down 2. So there's kind of my, I'm at home. So it went down 2 on that one. All right, I'm going to check in the next one to put in our x squared plus 2. This one went up 2. We now have a y-intercept at 0, positive 2. I'm going to make a rough sketch. Okay, for the next one we have 2 f of x. All right, so here's my graph. We got a point here at 0, 0. I can also tell we have a point here at 1, 2. 1, 2. and negative 1, 2. Is there another point I can pull? Let me see, what's this? What's 2 at? 2's at 8. 2, 8, and negative 2, 8. So this one you should notice it got narrower. So I took my graph, I stretched it vertically because it's outside the parentheses. This is a vertical stretch by 2. This one says 1/2 f of x, so let me go get that in there. 1/2. This one's got, I took it and stretched it out wider than the original one. This is a vertical, it's not a stretch, it's a vertical compression. I'm squishing it down. Vertical compress by 1/2. It's not even by 1/2. Oh my gosh, it's by 2. Okay, we got a point at 0, 0, and we should notice that it got wider. You can kind of see I kind of gave up on trying to pull points and just sketched a wider graph. So it was vertically compressed. I took it up and down and squished it. Last 2. Let's wrap this up. Which of the following sequences fits the description? The first term of the sequence is 4. That doesn't help us, they're all 4. It has a common difference of 2. Common difference means we are subtracting by 2. If it said common multiple, that would be different. So which one's subtracting 2 every time? C. Okay. For our last one, here's our formula. P equals 2L plus 2W. Says we are solving for L. We're going to solve it by doing opposite operation. So if I want to get rid of plus 2W, you do minus 2W. So P minus 2W equals 2L. We still need to get this L by itself. So this is 2 times L. The opposite of multiplying by 2, dividing by 2. Our answer should be B. Good luck on Thursday and Friday. Peace.